So now that I've gone through and added sounds to my game, I have some basic bumper sounds, some slingshot sounds, there are some hits that my flippers will make now, as well as some success sounds when these tiles are all dropped. I'm going to add one of the last things, which is a spinner. After the spinner, we'll be adding a forced movement volume, and then it'll be just onto aesthetics, so we can clean everything up. So for the spinner, what I'm going to need to do is import a couple of extra assets. Now these assets are going to be sm underscore L bracket. Just going to import that. I'm also going to grab sm underscore spinner. Let me just, there it is there, spinner tile. So this is the tile that's actually going to be spinning. And finally, the last one that I'm going to need, sm bracket top. So this one just here. I'm going to drag that in. We now have the three meshes that we're going to need to make our spinner. So import that. So to do this, what I'm going to do is create a new blueprint. And it's going to be an actor. And I'm just going to call this bp underscore spinner. Now I'm going to need a couple of things in this. So first off, what I'm going to need is the bracket tile for the left and right brackets to be set up. So I'm just going to add a static mesh component. And this first one is going to be the left bracket, which you can see is here. And I'm going to move this 100 units to the left, so negative 100 on the x-axis. At which point I'm going to duplicate this. And I'm now going to put this one to be 100, and I'm going to rotate it around so that we end up 180 degrees. It'll be sitting just like that. Now, with the left and right brackets in place, the next thing for us to do is going to be to add the top. So I'm going to quickly just name these left bracket, right bracket. And now I'm going to add the top, which is again going to be a static mesh component. And this is going to use the top bracket that we have before. And you'll notice that when I add this, it automatically is set up to have this kind of effect. So there's a couple of ways that I can handle setting this up correctly, but the easiest of those is going to be if I move it to here, and then I just scale it by 2 along the x-axis. Now, if I just enter 2, it's going to scale on every axis at once. So be sure to disconnect that and then enter 2 on just the X. And you should end up with something that looks like this. So that's going to be our basic bracket. And if we wanted to, we could set this up in a couple of different ways. We could, for instance, make these brackets taller. And if these were taller, we could easily resize it such that the spinner would be based on the ground. It depends really how you want to use this, so I'm just letting you know that it's available. So if I push those two up, for instance, I could then easily bring this up, at which point you have this kind of shape. I might actually keep it like that just so it's a bit easier for you to see what's going on. So with this in mind, the next thing that I'm going to do is I'm going to add another static mesh, and this is going to be, I can do a search for cylinder, and I'm going to use one of the basic engine shapes for the cylinder. So if I drag this up, this will be kind of the pivot location for the actual spinner as it spins around. So this should be reasonably straightforward for this one. One thing I will do on this though is I'm going to be a little cheeky and turn off collision on it entirely. So that's shut down. Now for us to get a good shape on this, I'm going to get to the scale tool by pressing spacebar, and I'm just going to shrink this down so that it looks about right. That's good. And then I'm just going to scale it outwards so that it just pops through the ends. Oops. There we go. So it pops through the ends, and we've got something like that. Now before I go any further, I'm going to quickly set up the assets themselves so that the metal bar is actually a metal bar. For these assets, I'm going to set them up within the assets, so within the static meshes. So I'm just going to double click on this, and I'm going to set each material to be just reasonably basic. So I'm going to set this to be simple yellow plastic with the metal. Save. And then I'm going to do the same thing for the top piece that we have, so the bracket top, which is also going to be, actually I might make this the white plastic, just so we have something that looks a bit different on it. There you go. Simple as that. Now that I've done this, I can see that there's a tiny bit of clipping. So the easiest way for me to fix this is to just add like 2 centimeters to the top so that it's just slightly above. That worked. 102 on the Z-axis. We've now got this, and I'm going to name these before I go any further. So top bracket, and static mesh is going to be, the last one is going to be called a cylinder. Okay, so I'm going to add another component now, and this is going to be the actual spinner. So I'm going to add a static mesh component. I'm going to call it spinner, and I'm going to set the mesh to be the spinner tile mesh. So you can see it's just here. It's a good idea to now move it up, get it to a location that's going to work for what we want to do, and that seems about right, because ideally we want this to kind of hit here, and if the ball's going one way it'll flip up, and if the ball's going the other way it won't let it through. So we've added this to here. We've got ourselves a reasonably straightforward tile piece. What I'm going to do is I'm now going to add a very basic physics constraint that is essentially going to act as the bar that will force it to spin or not. So to do that, what I'm going to need to do is go add component and physics. And I'm going to add a physics constraint. Now for this physics constraint, you'll notice that we have a couple of options here. Essentially what we'll be doing is we'll be telling the physics constraint to stick to this and let it twist around it in only one direction, and as far as everything else is concerned, don't let it move. So I'm going to bring the physics constraint up to this, just so it's connected to where this bar is. And at the moment you can see these circles dictate what would happen with this if it were to be connected. So let's actually connect that. I'm going to go to my component name, and I'm just going to name this component spinner in this. And you'll notice that upon hitting enter, it's selected the spinner component. Next up, I'm going to scroll down, and you can see that the angular limits are all set to free, free, free. So what that means is that this is allowed to swing on that axis, and our axis. But I don't want that. Instead, I want to lock it, and I want to set this one to limited. So by setting this to limited, I know that it can only be spun in one way. Now, the next thing that I'm going to be doing is I'm going to get this, and I'm going to tell it that the twist limits are going to be set for us. So see this section just here? That actually represents how this will spin. And if you think about how we want this to spin, we actually want this to be 90 degrees instead of 45, because it's 90 and 90, so it kind of does it in both directions. And then I'm going to offset this until it's around the other side. So I'm just going to go to here, and I'm going to type in -90. Now, the final part that I'm going to do is actually I'm going to quickly add 90 to my X rotation up here just to finish it off so that the axes kind of align. So I've added -90 to my X rotation, set that to 90 and that to -90. And we now have this. And if I were to then go down and I was to set up one last setting, which is under twist limits. So if I look at this, I can see that under angular limits, there's a couple of extra options. I'm going to disable soft constraint. We can hit compile and save. Now first off, whenever you do a physics simulation, always hit simulate first, because half the time it just falls down, which means you've done something wrong. But this looks like we're all correct. So the last things to do to get this working before we continue is make sure that the spinner has been set to simulate physics. And one final thing that I really like to do is to add an arrow component, because the truth is that we don't know which way this is going to be when it's in the scene. So I'm going to drag this up, and I'm just going to make the arrow point in the direction that I know this is going to spin in. Compile, save, and now if I were to hit play and fire it, you can see that it goes through there. And if I look at how this is set up, I can see that the arrow is pointing that direction. If I were to turn this around so that the arrow is pointing against the ball, now, the reason that didn't work the first time, but did work the second time, is due to an issue that we get from CCD. So for us to fix this, what we essentially need to do is tell the game that it needs to actually look at the collision of the ball more frequently than we have been. Because what it was doing is, in between ticks, it somehow jumped between this side and this side. This is a common problem in video games, and I'll show you how to fix that. I'm going to go ahead and I'm going to change a couple of settings on the ball just to make sure that these type of issues never really happen again. So in this case, the ball's going to need the following changes adjusted to it. We're going to need to make sure that when I go through here, we've set ball mesh. I'm going to scroll down, and the first thing I'm going to do is I'm going to enable CCD, which enables continuous collision detection. The next thing that I'm going to do is I'm going to increase the position solver iteration count, which is in the physics section here. So if I go to this, I can now actually tell it to more frequently check the position of the ball to make sure that we actually stay reasonably accurate. So I've set this to 12 and 2, and then I'm going to hit compile and save. And this shouldn't now happen again. You can see that now if I do a full charge straight into it, it's getting blocked every time. So we know that problem's now been fixed. So the last thing I'm going to do is put this into a place where I think it'll look good. In this situation, we want the ball to be able to go through here, but not necessarily back, for instance. I could put this over here, and I could set it up that way. There are plenty of different locations that you could put this, but I personally really like it being over here as kind of an entryway to the game itself. Again, I'm going to use this arrow to make sure it's positioned the correct way. So, flip it around, and I'm just going to pop this right here. Now, since it's a little big, I'm going to scale it up. That should all work totally fine. However, we are going to get an issue that it's possible for us to not really get enough momentum to get through that sometimes, and I'll show you how to fix that next. But here's a quick demonstration of what I'm talking about. Okay. You can see that it now pops out, and the ball's never now going to get back into that area. So we'll be moving into forced direction volumes next. However, one last little detail to change here is I'm going to set this to not be gray. So I'm going to open up the mesh that's associated with the spinner, which is just under Assets, Spinner Tile, and I'm just going to set this to be white. Save. So that's our very basic spinner, and if you wanted to go further, you could potentially get this to award points as well and have a couple of them around the map and set up some more complicated behaviors. It's up to you. But onto forced direction volumes, coming up next.